My dear students of class 10, hope all of you are well and washing your hands regularly with hand sanitizers. In my previous video about the periodic properties, I discussed up to the electron affinity. Today, I shall start from the periodic properties electronegativity. So, what is the definition of electronegativity? Electronegativity is the property of an atom in a molecule to attract the bonding pair electron towards itself. It has no unit. It is a comparative value, and if we look at the whole periodic table, fluorine has the highest electronegative element, and according to the molecular scale of electronegativity, it has the electronegative value 4. Now, on which factors this electronegativity depends? Mainly two factors. One is atomic size, another is nuclear charge. If we increase the atomic size, electronegativity decreases as the distance of the last electron from the nucleus increases, and it will feel less attraction to our nucleus. Next, nuclear charge. If we increase the nuclear charge, the electronegativity will increase as the size decreases and the attraction force increases. Now we discuss the variation of electronegativity in a period or in a group in a periodic table. Now if we take the example of third period elements like sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Here the values are written. Sodium has 0.9 electronegative value, magnesium electronegative value is 1.2, aluminium 1.5, silicon 1.8, phosphorus 2.1, sulfur 2.5, chlorine 3. So on moving across a period from left to right, the electronegativity value increases. Now in a group, whenever we are going down, the electronegativity value decreases. Now what is the cause? In case of period, when we are going from left to right, the size decreases as well as nuclear charge increases, so electronegativity value increases. But in case of a group, when we are going down, here from fluorine to chlorine we are adding new cell, so the size increases and the electronegativity value decreases. Now we have to understand this electronegative property properly. If we consider the HCl molecule, hydrogen has the electronegative value 2.2 and chlorine 3. So the electronegative value of chlorine is greater than hydrogen. So it will attract the bonding pair electron towards itself, and chlorine will acquire some delta negative charge and hydrogen will acquire some delta positive charge. So now this bond becomes polar. Now electronegativity has great application or huge application in chemical bonding. If we think about the compounds like hydrogen, where the difference between the two hydrogen atom electronegativity is 0, then the type of bond is covalent. If the electronegativity difference between two atoms is very high, then the type of bond will be ionic. We can take one example of sodium chloride. So here electronegativity difference between sodium and chlorine is very high, so sodium will lose one electron and chlorine will accept one electron, and there will be complete transfer of electron and the type of bond will be ionic. Next, we will discuss the metallic and non-metallic character. This is another periodic properties. Now from lower classes you know what are metals and what are non-metals and their characteristics. Today I will tell you one thing, that those elements have low IP value, that means ionization potential value. They can easily lose electrons by gaining some amount of energy. They are called metals. And those elements, they can gain electrons very easily and forms the negative ion. We can think about chlorine accepting one electron forming Cl minus. They are called non-metals. Now these metallic and non-metallic character depends on two factors. One is ionization potential, another is atomic size. If we increase the ionization potential, metallic character will decrease, but non-metallic character will increase. And if we increase the atomic size, the metallic character will increase, but non-metallic character will decrease. Now we will discuss the variation of metallic and non-metallic character in the periodic table. First, in a period, if we take the example of third period elements like sodium, magnesium, aluminium, silicon, phosphorus, sulfur, fluorine, argon. Sodium, magnesium, aluminium are metals, silicon metalloid, phosphorus, sulfur, chlorine, argon are non-metals. So, on moving from left to right in a period, metallic characters decreases, non-metallic character increases. Now, if we take the example of group 17, so in group 17 there are fluorine, chlorine, bromine, iodine, acetylene. So here if we go down, then their metallic character or non-metallic character will decrease. Better we can take one example of this, that carbon, silicon, germanium, tin, lead, group 14 elements. So carbon is non-metal, silicon, germanium metalloids, tin and leads, they are metal. So from top to bottom in a group, metallic character increases. As the size increases and IP value, that means ionization potential, decreases. So next we will discuss the study of alkali metals and halogens. Now what are alkali metals? Alkali metals are those metals when they will react with water form alkali. We can think about group 1 elements, they are called alkali metals. Why? Suppose sodium. Sodium is reacting with water forming sodium hydroxide. So sodium hydroxide is a water soluble base and is called alkali. So except hydrogen, all the metals in group 1 are called alkali metals. Now if we think about the group 17 elements like fluorine, chlorine, bromine, iodine, acetylene, they are called halogens. Why they are called halogens? Because they can form sea salt. That is why they are called halogens. Now we will discuss their properties. First, in case of alkali metal, if we think about the valence electron, the number of valence electron is 1 in each case. Suppose sodium, potassium all have 1 valence electron, so their valence is 1. If we think about their physical state, they are very soft in nature. Even we can cut by knife. If we think about density, their density is very low and their density is less than water. If we think about melting point and boiling point of the alkali metals, they have very low melting point and boiling point. As they are metals, they are very good conductor of heat and electricity. And if you think about the compound formation, they generally form ionic compounds. We can take the example of sodium. Sodium will combine with non-metal chlorine and forming sodium chloride, that is a ionic compound. Next, electron affinity and electron, they have very low electronegativity and electron affinity value. Now their nature, generally they are reducing agent. We can take one example, that sodium losing 1 electron forming Na plus. So this is an oxidation reaction. So the nature of sodium is the reducing. So this can act as a reducing agent. And if we think about their reactions, sodium, potassium rubidium, cesium, all are very much reactive. They will react with even in cold water and they will form alkali. Like sodium is reacting with water forming sodium hydroxide. If we think about their hydroxide like sodium hydroxide, potassium hydroxide, they are basic in nature and they will react with acid forming salt and water. And if we think about these alkali metal oxides, they are also basic in nature. They also react with the acid and forming salt and water. So next we will discuss the properties of halogens. Halogens are group 17 elements and they have 7 valence electrons. So their valency is 8 minus 7 is equal to 1. And if we discuss about their physical state, they are gases, they are liquids as well as solids. First, fluorine gas. Fluorine gas is yellowish gas, chlorine gas is a greenish yellow gas, and bromine is a volatile liquid, and iodine is a grey solid. Next, we will discuss their melting and boiling point. In case of gas, they are low, otherwise it is increasing. And regarding the conductivity, they are bad conductor of heat and electricity. And compound formation, they generally form covalent compound. We can think about that any fluorine is combining with hydrogen forming HF, that is a covalent type of compound. Now their electron affinity and electronegativity value is very high. Generally halogens are more electronegative elements in this periodic table, and generally their nature is oxidizing. If we think about chlorine generally accepts one electron and forming Cl minus because it gains the nearest noble gas argon configuration, becomes stable, and the type of reaction is reduction. So chlorine can act as an oxidizing agent. Now we discuss their type of reaction. Generally they will combine with metal, like chlorine is combining with iron forming ferric chloride. Now ferric chloride is a covalent compound, and we think about this fluorine, they are very much reactive and they react explosively with hydrogen gas forming HCl or HF. And another type of reaction is there that more reactive halogen displaces the less reactive halogen. So chlorine reacting with potassium iodide and displaces iodine from potassium iodide and forming iodine. So whole solution turns brown color, and in this way I have completed this periodic properties chapter and hope all of you can understand. If you have any question, you ask me by phone, otherwise you can mail me, and my email address is ppday.orchem@gmail.com. And in this way I have completed this chapter, and next video I will teach you chemical bonding. Thank you students.